Okay, I think we can start. This week we're going to have a single hour. And in this hour, what I want to discuss is simulation. Simulation is a technique that evaluates a certain decision that you want to give in different type of problem environments. Now we're going to see an example today. We're going to start with an example. And after that example, I will try to generalize the issues of simulation. And that example at the same time serve for definitions of some new notions, I should say, although I mentioned it in previous weeks. And these notions are going to be useful in the courses that you are going to see, as well as in this course as well. So before actually discussing what simulation is, let me start with the example which is given in the reading assignment for this week. Now, the example is quite simple. Let's say that we already discussed these type of issues in the beginning of the semester. Let's say that we are interested in some kind of a club activities and we are trying to raise money. So remember, in decision analysis, we had a similar issue on hand. But this time, let's say that we are going to do again something else to raise some money for club activities. Now, assume that the university has a basketball team and there are 10 games a year which are already planned. I think in the coming years we may expect something like this happening in Turkey as well. It used to be like that. There were some pre-scheduled games. Now what they have is they have a pre-scheduled long weekend where all the games are played in a single location among different universities. Whereas previously it used to be every week there would be a game scheduled and then there would be finals. It would be like a regular league. Okay, so assume that this basketball game will be, you're going to have 10 games a year. And all of these games are going to be held somewhere at Bilkent. So what you want to do is you want to sell hot dog in order to raise some money. So this is the problem which is actually exemplified in your reading material. Now, you can assume that all tickets are sold out. Everybody is very much interested in to see the basketball game. And so each of the games that are played will have equal number of audience so that they are similar to each other. Okay? So we can generalize certain things. Now, although you are going to sell these hot dogs, there is a certain decision that you should give in the beginning. How much hot dog to prepare for each game? Okay, that's a decision variable. Now, we're going to analyze that decision situation and see what we can do for that. Now, we know that the selling price of a hot dog is $2. Okay? Buns, which are specific name given to the sandwich bread of hot dogs, it's basically a sandwich bread where you place the hot dog inside, you can buy it to $144 per dozen. Okay, so it's not very expensive. And hot dogs can be bought to $6.56 per dozen. Note that it's not important because the number of buns that you are going to buy will be comparable to the hot dogs that you are going to buy. So we are always going to deal with the sum of these two numbers. So a hot dog and a bun is going to cost you $8 per dozen. So 12 of them, you're going to have $8. Now, of course, you can see that you are selling each hot dog to $2. So if you can sell all the hot dogs, then it means that you will make $24 per dozen. $8 is your cost. The remaining is going to be the contribution that you have from sales. Now, of course, there is one issue. You might have some buns, some hot dogs prepared, but unsold. So what you can do is, the only thing that you can do in this problem environment, you are going to donate it to a place. So you are not going to get any money out of that. Now, if you cannot donate, then you have to throw it away because they are not going to be good for the next day. Okay. Any problems with this explanation? Okay. Now, what will be the sales? Of course, the main issue here is that we don't know what the sales will be. Okay? And this is unknown ahead of time. But of course, we may have an understanding of what are the possible values for these sales. Remember, we are now, with the experiment that we had in the class a couple of weeks ago, we have an understanding of how we can represent this unknown issues, which we call uncertainty. And of course, the sales is unknown ahead of time, but we are experienced in selling hot dogs in basketball games. We have data from the previous years. We have data from similar universities. Okay, we might have it available. So the outcome is unknown, but we know, for example, the range or the chances of having certain values. So this is what we're going to do about that, actually. Now, for every game, you can have some preliminary analysis. You can analyze the data, or you can do various different things, which I'm not going to do today, actually. I would ask you to read that, how you can come up with some explanation of the demand. But we know that eventually, after doing some analysis, we can come up with a range of values for demand, which we are going to use for this purpose. And the chances of having each of those values can be obtained. I'm just assuming that we are not going to obtain it for this case, but if you remember what we did with the die, with tossing a coin example, or with the rolling a die example in the exam, we can come up with a specification. So the outcome is unknown, but we have some kind of a knowledge on what the possible values are. Okay? Any problems here? Okay, but of course, this is something which is important. You're going to see these type of things in different courses, in statistics course, in production course, where you're going to do forecasting. You're going to forecast what the demand would be. And you're going to learn a lot of things about how to predict sales that will come in the future. You always have some information, okay, either by analogy, or you may have information on similar issues. Okay, now let's do some analysis with respect to what will happen if we sell a dozen of hot dogs, if we sell other types of hot dogs, or other quantities of hot dogs. So what I will do is, now I will basically write a table here, and we're going to fill up that table. So the columns that I'm going to have will be, the first one, I wrote it in red specifically, because this is going to be our decision. In other words, we're going to prepare for a certain number of hot dogs and buns. Okay, that will be our decision. Okay, so given that we have this decision, we might have different outcomes. Okay, so the rest of the columns are going to explain those outcomes. Now, this is in dozens. So I'm assuming that I can make the decision not in units, but in dozens, just to simplify the exposition of the example. Now, let's say that the random demand, there is a random demand that I cannot control, and this is going to be in dozens. There's a certain value that I observe. Now, what I want is, I want to compute the effect of my decision on the outcome. Then what I will do is I will find out the quantities of hot dog which is sold. Again, this is going to be in dozens. Note that this is actually the units that I am using. You have to know the units, whether it is a single quantity, dozens, or hundreds, or whatever. Then I will be able to compute the total revenue which is going to be in dollars if this happens. And of course, I'm going to have some kind of a fixed cost for the week because of my decision. And then I can write the value of the profit, which is equal to revenue minus cost. And this is also going to be in dollars in the last column. Now, note that here, once you decide on the number of hot dogs, the number of dozens of hot dogs and buns to prepare for the game, you are spending some money because you have to buy them, okay? So you are spending that money, and that money is not going to, you won't be able to get that money back. So that's the reason why here I said weekly fixed costs, once you decide on the number, that will be the cost that you are going to pay. Now, when you start selling buns, you are going to get some revenue. Of course, if the revenue is more than the cost, you are going to obtain some profit. Okay. Now, so what I will do is now I will write certain possibilities. These are not exhaustive possibilities. These are just some possibilities that I thought would be interesting. Let's say that I ordered 16 units, 16 dozens of bread, hot dogs and buns, 16 dozens. So let's say that this is for week 1, and I am going to consistently order the same amount, because if it is a good amount for week 1, it will be a good amount for week 2. Weeks are independent of each other, of course. I mean, as long as we have the same population, a similar population who bought tickets for the game, we will have the chances of selling it. So in week 1, this is, let's say, the demand turned out to be 9 dozens. So we are prepared for 16, but the demand turned out to be 9. So how many dozens of hot dogs we will be able to sell? Well, as we have already available buns for more than 9 dozens, we will be able to satisfy all the customers. So we will be able to sell 9 buns, 9 dozens of hot dogs and hot dogs. So the total revenue that I'm going to obtain will be what? Let's compute that. So I'm going to sell 9 dozens. For each dozen, what is the revenue that I obtain? 24. Actually, let me write this as 2 times 12. This is $2 per unit. And 12 is the number of units in a dozen. So this is 9 times 24. And so as a result, I'm going to have $216 as my revenue. Now, what is the weekly fixed cost? I need to buy, well, if this is my decision, I am going to have 16, and each dozen is going to cost me $8, if you look at the data in the previous slide. Okay? And as a result, this number is going to be 108, and my profit will be $108. Now, here still I don't know what is the chances of having demand 9, but I'm simply trying to figure out the effect of my initial decision. Okay, this is 128. Okay, you're right. And then this is going to be 72, 82, $88. Okay. Okay, any questions so far? Now, let's say that I am sticking with my decision. So in week 2, I am still going to observe the demand. Let's say that in week 2, the demand was 13 units. I still am prepared for 16 units. So how much can I sell? I can sell all the 13. So this is going to be 13. Now here I have 13 times 24 this time. So 13 times 24 is going to be $300. 12, if I didn't make a mistake. Okay? And of course, the weekly fixed cost is going to be the same because I am prepared for 16 dozens. So this is going to be 128. As a result, I'm going to have $184 as my profit. Okay? Now you can say the following. Now I can continue this example for 10 weeks, but I am not going to do that. The idea here is that this looks very nice and simple, but you always have the following in your decision. Now, what if you have ordered exactly 13 units rather than 16? What would be your benefit of knowing the demand exactly? Or, if I put it in another way, if you knew, which is not possible, by the way, to know, but if you knew that demand would be 13, you would order less. Actually, you're going to order, of course, 13 units. Am I right? You're not going to order more than that if you knew that it's 13. And what would be the total profits in that case? So the money that we spent for 3 additional dozens would not be spent, and that money is going to come as a profit. So total profits would be 184, the current one, plus what is the cost of 3 dozens? 8, and so we have 24. So this is going to be 208. So you can see that this is, or in another way, I can do the following. $24 is the loss of overordering. Okay? Because you ordered more than the demand, and that's the cost of overordering. Now, let's keep that in mind because I'm going to use that in creating a mechanism for the logic of giving this decision. Okay, any questions on this? Okay, so let's go a little bit further. Now I'm going to use the same table, but this time, so, well, let me use this bottom line. This time, what I will do is, instead of ordering 16 as a reaction, because I'm noticing that I am always going to have some units available at the end of the week, which I don't want to do that. So let's say that I ordered 1. I ordered 9 units rather than 16. So if this was my decision. So what I can do is I can still do the same thing for different values of demand for different weeks. Observe that and see. Unfortunately, in real life, you don't have enough time to do this. Because, you know, like if in a given year, let's say that you tried 16, next year you tried 19. I mean, how many years do you need to have in order to try all possible numbers? So this is not possible. We have to do something beforehand, actually. I mean, this is the reason why we are dealing with this problem. Okay, but let's say that we have ordered 9, and let's say that in the suitable week for ordering 9, the random demand turned out to be 14. Now, don't ask me how I am accounting for people after I'm finished with the hot dogs. How can I see whether another person is asking or not? You can still keep the same kiosk if you have a kiosk there. So if people comes and ask for hot dog, you can simply put a mark. Okay? So you are never going to let everybody know that your hot dogs are finished. Okay? So you can actually take some kind of a account of the people who are going to come after everything is finished. So let's say that the demand was 14. So how many hot dogs can we sell in this case? We can only sell 9. actually the number of hot dogs that you can sell is the minimum of the demand and the quantity which is available. Whichever is the minimum, that would be the number that you can sell. Okay, so it means that we will be able to sell 9. What will be the revenue that we can obtain? We already did that computation, 216. Okay, what will be the weekly fixed cost that we have? It's 128. So the profit that I have is only $88. Yes, okay, this is not 128, I'm sorry. I am only buying 9, so this is going to be 72. Sorry about that. So my profit would be $116, $140. 44, excuse me. Yeah. Okay. Thank you. Okay. Now, again, at this point, I lost some money because if I predicted the demand, I would be able to order more and make more money. So let me write that over here. So if you knew exactly the same words, you knew that demand would be $14, okay, then you would have ordered 14. I'm not going to write that, okay? And the total profits that you would obtain in that case would be what? Well, the current one, 144, plus we're going to have, for each dozen, we have a profit of 16. So if I ordered 5 more dozens, it would satisfy the demand. So this is going to be 5 times 16, which is 90, and then the result will be $234. So this would have been my profit if I knew the demand.
It must be 224.
224. Okay. Okay, thank you. Okay, so this is going to be 224. Now, what does this mean? It means that if I use the same kind of wording, $80 it would be, can be called as loss for underordering. But just for this case, of course. So you can see that depending on the outcome and depending on your decision, you are going to either have overordering or underordering. If you're lucky, which is never the case actually, you're going to order exactly the same amount of demand. Now, as you don't know this, you are always going to have the risk of overordering and the risk of underordering. So this decision is based on the trade-off of, there is a trade-off in this decision between overordering cost of overordering and cost of underordering. But of course the problem is not that simple because you don't know the outcome. There are some possibilities. Now your decision should accommodate these two costs and make sure that you optimized your decision. Now you're going to see these type of problems in 375 and 325 up to a certain extent. This is basically an inventory problem. How much inventory should I start with so to optimize my revenues in the future? Okay? So this is a typical problem that industrial engineers make decision. Okay, this is the typical problem. But at this level, you can see that what we did is basically we made this hot dog sales business. We tabulated the values. Now we know how to compute the profit if you give me everything. And I still don't know how to make this decision. But I can try different things, of course. Now, one thing that comes to mind is, why don't I try a lot of demand possibilities, if I can, on the table, and then see the effect of that. But that wouldn't mean much, because the chances of having a demand of 9, chances of having a demand of 13, or chances of having a demand of 14 is not, I still don't know that. But if I knew that, I would be able to use that information as well. Okay? But still, I didn't use that information. Okay. Any questions? But this is the place where simulation is going to come into the picture. Okay. Any questions on this? Okay. Let's continue with the slides. So sales, it's unknown ahead of time. We can do something about that. This is something that I already talked about. And you might have a scenario where you have over-ordering. Or you might have a scenario where you might have some kind of an under-ordering. Now, we know how to compute those if we know the outcome. Now, the next thing is, we need to understand the demand. So we're going to develop a model for demand. So how are we going to do that? This is not easy. We are going to use past data. Now, I'm not going to go over that, but if you look at your notes, you're going to see that this will be a similar experiment as we had in the classroom. You can come up with some kind of a model prediction. Now, on the other hand, we are going to use simulation to understand the effect of our decisions. Okay? And what is simulation? Simulation is a very flexible technique. What it does is it models the real system and by representing it in the computer. So you can say the following: how are we going to represent hot dog sales in the computer? It's very simple. You can animate it, for example. By animation, actually, what you are doing is you are observing people coming to your kiosk. If there is a hot dog available, you are selling that. You're taking the cash. Otherwise, you're not selling it if there is no hot dog. But you're recording the customer. Okay? Now, you can do it. It's very simple. You are all very much familiar with these type of simulations. Now, you are familiar with flight simulations, or you are familiar with video games. Video games are actually simulations. Now, think about, you give a lot of decisions in certain video games. For example, you are jumping from one place to another. You make your character jump from one place to another. And what happens is that once you make that decision, according to the way that you perform your decision, the computer program that is playing underneath this is basically mimicking the real life, in a sense. So what simulation is, in our case, is we have set of processes, as we have discussed in the beginning of the semester, together with a possible set of decisions. Okay? Now, I represent this in the computer and make the computer apply my decisions to the circumstances that it faces. So this is basically what I do. Okay? Now, if I go one step further, in hot dog sales, what I will do is, this is one possibility. I'm going to create a demand randomly. What's the meaning of creating a demand randomly? Is you're going to have one fellow coming to your kiosk. Okay? And you're going to create that in the computer. So if one hot dog is available, you sell it. Otherwise, you don't sell it. You record the total revenue that you received. And you can do it in the computer. Now, there are other possibilities. You have a course devoted to how to simulate systems. So you're going to have a simulation course. You're going to learn other possibilities as well. But the basic idea is, what is the advantage? The advantage is, in real life, in order to be able to do this, I had to wait weeks. Every week I'm going to get a demand value, and I'm going to write my profit. And maybe to test certain things, I have to wait for years. Instead, what I'm going to do is, using the demand models, using the computer simulation model that I have, I'm going to make everything live faster. Okay? I'm going to simulate this game business for 300,000 years in 1 millisecond. Okay? And record my profits for every possible outcome given a certain decision. So what does this mean? It means that if my demand model is reasonably correct, I will be mimicking real life, and instead of waiting for years, I'm letting the computer live faster, move from 1 week to another, and find out the effect of my decision on the case that I describe. Now, it looks very appealing, of course. You can say, then why don't we use this simulation everywhere? Let's forget about everything, just use simulation. It turns out that to build up good simulation models is not always that simple. Hopefully, you're going to see it in the simulation course. Okay, but the idea is that as computer lives faster, you can evaluate the effect of your decisions in a fast way, assuming that your computer model is a correct representation and your demand model is reasonably well fitting what you have observed in the past. Okay, any questions on this? So what I write here is actually might be the steps of a computer. If I was able to write very quickly in milliseconds, I would be able to write thousands of rows giving me different demands, and will be able to compute that. And at the end, if my random demand model, my representation of demand is correct, at the end I will simply take the average, find out the cost that will, the profit that I'm going to obtain. Okay? So this is more or less the idea of simulation. I think if you read the text, it will basically complement everything I said here. It's a very appealing technique, but it's not as easy to construct, and you're going to have very difficult experiences in the simulation course, because in that course you're going to prepare a project, and you're going to see how difficult it is to represent a real-life system, even if the system that you will be described will be very simple and actually very concisely described. Okay. Questions up to this point? Okay. Now, the key in simulation is, of course, how are we going to generate, it's called generation of demand, like customer coming in. You generate it, actually. How are we going to do that? And this is one of the keys. You have to have a good representation of demand. We do it, and basically, once we can do it, this is going to be simple. So, for example, the last sentence that I have here is, this is typical inventory decision. We're going to see more elaborate ways of dealing with this decision. Actually, this decision doesn't necessarily mean simulation as an aid, because you can more simply evaluate the effect of different decisions in a more rigorous way using mathematical models. But the idea is still the same. Okay. Now, the next few slides, which I'm not going to spend time up to the last slide, from 9 to 17, is basically describing you how we can represent the past data that we have here is as a function to be used to randomly generate the demand. Okay? And this is very similar to what we did in that we had two different cases. One of them is the exam question. The other one is the experiment that we carried out. And if you read, this is like a third example of the same thing. But this is a little bit more elaborate because we have a data that we can use. Okay? So you can follow that actually. If you read that, you will be able to follow that. Instead, what I want to do is I want to talk about probability in general, what it means, so that it will be helpful to understand this part as well. Okay, so next thing that I will do is I'm still going to use the board. And so let me erase this part. So let's say that after some effort, we were able to represent the demand. So as a result of representation, we obtained a function in the following form. And I will explain that function. Now, first of all, we found out that demand can take any value between 3, these are all in dozens, of course, 3, 4, 9, and 18. So these are the possible values of the demand. Now, how did I obtain this again is over there. You can understand, actually, when you read that. There is some data that you use. And the probabilities of having this value being true, or we can still call it chances, okay? And are given in the following way. So this is going to be 1 over 216. Now, what's the meaning of that? On the average, if I look at this system long enough, I am going to see that out of 216 weeks, only in 1 week I'm going to have a demand of 3 units. 3 dozens, actually. Okay? So 4 is going to be 3 divided by 216. 7 is going to be 15 divided by 216. 9 is going to be 25 divided by 216. 18 is going to be 1 divided by 216. Now, the full distribution, the full information is given in your notes. But eventually, what you obtain is, after making analysis of the past data, you come up with this kind of a demand representation. Now, to generate the demand in the computer program using this is something that you're going to learn in the simulation course. So given this demand representation, you generate those customers who are coming or in a certain way, and this is basically what you're going to learn. What's that certain way? You're going to learn that in the course. Okay. Now, let me give some definitions. So given this representation, the first definition would be the probability mass function. And I'm going to call it PMF in short. And so what we have is, let P1, P2, P sub n, okay, denote probabilities such that P sub k is greater than or equal to 0 for all k. Okay? And so this is the way that you're going to read this. Probability that random function takes a value of k is given by P sub k. So in our example, n is 18, okay? And well, P1, P2 is having demand value of 1, 2, they are all going to be 0. If it is greater than 18, it will be always 0. And P sub n, for example, would be 1 divided by 260. P sub 18. Okay, so this is a function of that sort. And moreover, we're going to have summation k from 1 to n of p sub k equal to 1. And so if you have such p sub k's, this function that is made up of this p sub k's is called probability mass function. So it's a function that describes our demand, but at the same time, in more general terms, it has the following definition. Okay? Now, you are familiar with probabilities from high school. Okay? So I think this is basically, maybe you have seen something like this. But the requirement is that the summation of those probabilities that you define should be equal to 1. And each of the probabilities should be non-negative. You might have zeros in between, but the sum should be equal to 1. Now, we are not going to work, but there is a continuous version of the same thing. So from 0 to infinity, if you multiply x f of x dx, this should be, f of x dx, if you integrate a function f of x over all its possible region from 0 to infinity, it's going to be equal to 1. So this is the continuous version of the same probability, but this time this f of x is called probability density function. And this is the short of PDF. Now, we are not going to deal with this. You are going to be responsible for PMF, but PDF is the continuous version of the same thing. You're going to see these in the courses that you're going to take next year, actually. Start seeing it, actually. You're going to see in a lot of courses. Okay. Any questions? Okay. Now, one other definition, and this is the final one. And that's the expected value. Now, remember, we have been talking about expected values, but we never defined it. Now, we are in a position of defining the expected value. So this is called the expected value. And the expected value is defined as in the following way. You have E, and then you have the square bracket. And here, in this bracket, you will have K. Now, what is K? In this case, it is, let's say, the demand. Expected value of K is defined as K from 1 to n, K times P sub K. If you remember, we already did this type of a computation. What we did was we multiplied the chances with the value. Okay? And so this is basically how expected value is defined for a discrete system. Now, of course, you might want to evaluate the expected value of a certain function of k. This is a certain function of k, like profit function, which depends on the demand, okay, like the one that we have. And this is actually written in the similar way, but instead of k, we are going to have f of k. And this is the expected value for k. This is the expected value for a function of k. So f of k is any function of k. Now, in our case, this function is the profit function. What is k? K is the demand. We don't know which value of demand is going to come, but for each value of demand, we are going to have a profit, and we can compute the expected profit using this formula. Okay, now again, what do we do in simulation? In simulation, usually we deal with complex structures where to take this is not that simple, because you might have a number of different uncertainties on different values. Okay? In that case, if it is very complicated, what you do is we let the simulation live for long number of years, and then take the averages at the end, and then it will give us a possible value for the profit that we are going to have in the system if we follow a certain decision rule. So this is what we do in simulation. Simulation is a technique that evaluates your decision. It's not going to optimize your decision, but it will evaluate your decision. Okay? Now, questions? We will give some exercises, okay, so that you will understand and relate certain things. But before that, I think you have to read the chapter which is related with simulation. It's very easy to read. You already know how it is written, so it's very easy to read. Now, what I will then do will be to go to the last slide to just wrap up things. Now, simulation is a technique that can be used for various complex situations. This is the last slide, slide number 18. Now, there will be a number of courses which is related to simulation. Now, the computer courses that you are going to take definitely are related with simulation, because in those computer courses, you're going to learn how to materialize a certain computer program. Okay? Now, unless you understand that, it's very hard to understand simulation, because it will always remain as a black box to you. And you don't want it, actually. You have to understand how it works. So the other courses would be Math 250, Math 260, where you're going to learn expectations, statistics, how to create demand models. This is the place where you're going to learn that, actually. And IE-325 is one of the courses that you're going to see this random models with random variables. And another course, this is going to be the simulation course. Of course, we're going to have IE-375 and other courses which are going to basically use this material. Okay. So modeling here is the key, whether you are going to model the real processes in the computer to understand it, or whether you are going to model the randomness to understand issues. These are the key issues. These are our value as industrial engineers, actually. Because once you have the model, somebody else can put it in the computer and run it. But you have to be able to represent correctly whatever you see around. Now, analyzing the output of simulation is not that straightforward. That's one of the things that you're going to learn in the simulation course towards the end of the semester. It's always at the end of the semester, but it is definitely very important. Because unless you have a good analysis, it's not going to bring you much. Now, the ordering problem, how much should we order, is one of the issues that you're going to see in 375. So you can see that most of the things that we are mentioning are related to each other. The models that you select to solve certain problems, the approach that you take. And that's one of the reasons why I was telling since the beginning of the semester that the courses are definitely related to each other. You cannot assume that they are independent, and if I pass each of them without remembering what I did in the previous one will be sufficient. It might be sufficient, of course, you can pass, but important part is that if you really want to be a good industrial engineer, you have to make sure that you bring those things together. Okay, questions? Okay, I'll see you next week. Not next week. Next week we don't have lectures. The week after that.